Hi everyone. Now we are going to discuss about the last two characteristics of matter. Last class we have already learned about the first two characteristics of matter. Okay, let us see the next one. The third characteristic is the particles of matter are continuously moving. Before going to discuss this third characteristic, we have to learn some terms. That is, first one, Brownian motion, and the second term is diffusion. And these terms are very helpful to understand the third characteristic very well. Let me see what is this Brownian motion. The Robert Brown was the name of scientist who discovered this motion. And what he did, he took a glass slide. Okay, he took a glass slide and he placed a drop of water to it. Okay, he took a glass slide and he placed a drop of water to it. And he added the pollen grains to it. Okay, this is the pollen grains. Okay, his experiment is that he took a glass slide and he placed a drop of water to it and he added a pollen grain to it. Then after he observed it under the microscope. And what he observed? Okay, he observed that these pollen grains are moving in a zigzag way. Okay, these pollen grains are moving in a zigzag way. How it is happened? What is the reason behind it? Okay, here a drop of water containing 10 raised to 21 particles. Okay, a drop of water containing 10 raised to 21 particles. And these all particles are moving and they collide each other. At the same way, these all particles are hit the pollen grain from all sides. Okay, that is why these pollen grains are moving in a zigzag way. This irregular motion of the suspended particles is named as a Brownian motion. And secondly, he did the same experiment with the hot water. Okay, that is means instead of cold water, he used the hot water. And after the experiment, he observed the same thing, that is, these pollen grains are moving in a zigzag way. But in hot water, the rate of speed is greater than that of the cold water. That is means these particles are moving with a greater speed. This is because the factor of temperature. The hot water, it has a temperature. When this temperature increases, these pollen grains get energy, that is kinetic energy. Okay, when the temperature increases, these pollen grains get energy, that is means the kinetic energy increases. So its rate of speed increases. Okay, when the temperature increases, its kinetic energy increases. So its rate of speed increases. So we can say the irregular motion of the suspended particle is named as a Brownian motion. And with the fact of temperature, the suspended particles, they get a kinetic energy. So its rate of speed increases. The second term is diffusion. The diffusion means the spontaneous intermixing of particles by their own is named as diffusion. That is means the mixing of two or more particles. Okay, and two factors are affecting diffusion. The first one, temperature. The first one, temperature. And the second one, density. Okay, these are the two factors affecting diffusion. First one, temperature. Second one, density. Okay, this temperature is directly proportional to the diffusion rate. Okay, this temperature is directly proportional to the diffusion rate. When the temperature increases, the rate of diffusion also increases. And when the temperature decreases, the rate of diffusion decreases. Okay, this is the first factor, that is temperature. Temperature is directly proportional to the rate of diffusion. When the temperature increases, the rate of diffusion increases. And when the temperature decreases, the rate of diffusion decreases. We can see the second factor, that is density. This density is inversely proportional to the diffusion rate. That is means when the density increases, the rate of diffusion decreases. Okay, when the density increases, the rate of diffusion decreases. And when the density decreases, the rate of diffusion increases. Okay, is our second one diffusion. Two factors are affecting diffusion. First one temperature, second one density. The temperature is directly proportional to diffusion and the density is inversely proportional to the diffusion. These are the new terms. It is helpful to understand the third characteristic very well. Okay, let us back to the activity. Okay, let us back to the third characteristic, that is particles of matter are continuously moving. Okay, we are going to prove this third characteristic with the help of a small activity. So in this activity, we are going to take an unlighted instant stick. Okay, we want an unlighted instant stick. Then if you want to smell it, you need to move close to it. And the second stick, light this instant stick. Okay, and the second stick, light this instant stick. And after place any corner of your room, and you must be in the another corner. Okay, you can easily find the difference. You can smell the instant stick even from the distance. Its reason is that when we light the instant stick, its temperature increases. Okay, when we light the instant stick, its temperature increases. So the particles of instant stick, they get one energy, that is kinetic energy. Okay, so the temperature increases, this kinetic energy also increases. So these particles are very fastly mixed with the air. And the first case, unlighted instant stick, it is the room temperature. So these particles do not get any energy and they do not mix with the air. So through this activity we can clearly show that the particles of matter are continuously moving. Okay, let us see one more activity. In this activity we want to take two beakers and add equal amount of water to both beakers. Okay, take two beakers and add equal amount of water to both beakers. And if one drop of ink is added to the first beaker, give one drop of ink is added to the first beaker, and one drop of honey is added to the second beaker. Okay, this experiment is that take two beakers and approximately equal amount of water to both beakers, and one drop of ink to the first beaker and one drop of honey to the second beaker. Let it undisturbed for the some time. Then after we can observe that the ink is very fastly mixed with the water, but honey, it takes time to dissolve it. Okay, what is the reason behind it? It is because of factor of density. Okay, we already learned that the density is inversely proportional to the diffusion rate. Okay, so in the case of honey, it has high density. Okay, in the case of honey as compared to ink, it has high density. Okay, that means its density increases, so the rate of diffusion decreases. That is means it takes time to dissolve in water. Okay, and the second is ink. Okay, its density decreases. Okay, as compared to honey, its density decreases. So its diffusion rate increases. Okay, so through this activity, we can say the particles of matter are continuously moving. Let's move to the last characteristic, that is particles of matter have a force of attraction between them. Okay, now I am going to do a small activity. In this activity, I need three substances, otherwise three matter. That is first one, chalk. Second one, ice cube. And third one, iron nails. Okay, first one chalk, ice cube and iron nails. And what I am going to do, I will try to break these three substances with the help of a hammer. And which one can I break quickly? Do you know the answer? It is chalk. Because when I hit the chalk with the help of a hammer, it's very easy to break it to 5 or 6 pieces. And in the case of an ice cube, it will take time, but definitely it will. And in the case of an iron nail, it's very difficult to break it. So it is clearly shown that a particles of matter have a strong force of attraction between them. And this attraction is named as a cohesive force. In the case of a chalk, these particles of matter are very weakly attracted. They have a weak force of attraction between them as compared to ice cube and nail. And the second case, ice cube, as compared to chalk. Okay, as compared to chalk, they have a strong force of attraction between them. And the last case, iron nail, as compared to this ball. Okay, as compared to chalk and ice cube, they have a very strong force of attraction between them. So we can conclude by this activity, the particles of matter have a strong force of attraction between them. And this attraction is named as a cohesive force, otherwise intermolecular force of attraction. It is the last activity, that is Diffusion's activity. In this activity, we are going to do with the help of a 3 group of children. It is named as A, B and C. And each group containing 4 children. Each group containing 4 children. We can divide to 3 groups and each group containing 4 children. And I thought the first group hold their hands from back side. That is means analog. And the second group, they hold their hands as a human chin. Okay, they simply hold their hands like a human chin. And the last group, they touch each other with their finger. Okay, so first group, they hands down, and the second group, they hold their hands like a human chin, and the last group, they touching each other with their finger. And next, I am going to break this human chain one by one. Which group can I break easily? Okay, do you know the answer? It is a group C. Because they are weakly connected. Okay, they have a weak force of attraction between these children. So I can break this group C very easily. And in the case of first one, that is group A. Okay, they hold their hands from back side, that is anode. Okay, they have a strong force of attraction between them. Okay, so through this activity we can prove that the particles of matter have a strong force of attraction between them. So we have learned 4 characteristics of matter through an interesting activities. So next video we will see with another topic, state of matter. Until then, bye.